So the first output that I want is going to be the distance between these two handrails. So if I go into the 3DCS model, I'm going to go ahead and nominal build so we can see it here. What I want with this first measure is to measure the distance between these two white handrails. And I want to measure that on either of the ends, as that'll probably be where the extremes are. It's unlikely that the minimum or maximum is going to come up in the middle, so I'm just going to throw a measure at either of the ends. So for this first output, the first measure I'm going to be using is probably one that a lot of you 3DCS users are very familiar with, called the point distance measure. This is by far the most commonly used measure in 3DCS. Gary, what got a percentage of how many measures in 3DCS would you say are point distance?
80%.
I was thinking 80 to 85%. We're on the same page on that one. As far as your primary inputs go, primarily when I'm using a point distance measure, I'm either measuring a point to its nominal, so that would just take 1 point input, or a point to another point, which would be 2 points input. Another input is the measured direction. So there are also direction modes. You can also do different measure types here, but I'm trying to cover the most common use for this, and it's not that often that I'm measuring a point to a line, or I'm measuring projection on plane or true distance. Usually I'm using this measure to measure a distance projected on vector. That's not to say, we never use projection on plane or true distance, but more common use.
Yeah, generally we're trying to understand the variation along a direction. X,
exactly.
Y, Z, or any kind of defined direction.
And then, your best uses for this first measure, we're talking distance measures. You can use this for gap flush measures, or you can use this for, clearance check measures. Usually, if you're looking for a pinhole clearance, we'll get to that later, it's going to be a different measure. But you're just trying to see if, one face interferes with another face at a certain point. A point distance measure is going to be pretty effective to get that done for you. So jumping back to the 3DCS model, I have these two measures here, handrail width front and handrail width rear. And as I highlight either of them, you can see that 3DCS highlights what I'm measuring between. So with this first one, I'm measuring between this point over here on my left handrail, and I'm measuring to this point over here on my right handrail, and I've called this the front side of things. So I'm going to go ahead and recreate that measure. So if you're in your measures dialog, point distance measure is always going to be the first one that shows up. So I'll select add, then it'll open up the point distance measure dialog. Now you'll see this defaults to only needing 1 point input. It's because our measure type is currently measuring nominal to point. I'm going to change this to be point to point, and we'll see a second input field line up over here. Like I said, there are other input measure types down here, but I'm trying to cover the most common ones. We kind of have a lot of content to get through, so I'm just going to keep it at point to point.
And you'll notice that the most common ones are default settings.
Yes, exactly. So for my first feature, it's going to be the first measure that I'm measuring. The first point that I'm measuring for, I'm just going to go ahead and draw a box around my first point that I have over here. Didn't quite work. Every once in a while, the box is a little bit finicky. So I'll go ahead and head over to the tree here and find it there. So this is going to be one of my handrails, and it's going to be my front one measure. So if I click that, you'll see that it highlights that point. And then my other point that I'm measuring for would be right over here, front two. So now I have both those points in this list. Like I mentioned in the PowerPoint, we also have a measured direction that we need to input down here. It defaults to associate direction, which means that it's going to take whatever vector direction I have for the point I have selected in the from field. So currently in the from field, I have this left-hand point selected. So if I select direction, we'll see it picks up that arrow at the first point that I selected, and that's the direction arrow for that point. Now, if you wanted to change this, you could to any of the common input methods in 3DCS. These are common across all of our moves, tolerances, and measures. I'm going to leave this one to associate direction, as I do want to measure it in the direction across this handrail. And you can also see that we have a current value down here of 711.2. That means that as this currently sits, there are 711.2 millimeters between those 2 points. Lastly, you have your spec mode down here. It's pretty common practice. I'm just going to leave that as a spec mode of relative and then plus or minus 1. So that means that if this is 711 plus or minus 1, I'm saying that this is in spec. If I have more than 1 millimeter of variation in either direction, I'm going to go ahead and call this measure out of spec.
I don't know if everybody knows, but this is an active measurement, and so is it okay if you hit deviate, leave that up?
I believe it will be. So if I click deviate here, we'll see that my model is shaking around. You'll see that the value down here is not updating, but if I hit this current measure, we'll see that number change.
Right. So
it's kind of varying between,
So you could actually visually deviate your product, and if you see something that you'd like to know, oh, well, what's the number there? You can just go, keep the measure open, hit current, and it'll tell you what the measure is.
Or you could do this 2,000 times, and then you could have your own sample without doing run analysis at all.
Right. Correct.
I wouldn't recommend that. It's not a best practice. So that's a point-to-point measure. I'm going to go ahead and delete that since I already have my 2 measures up there. And I'll also close out of this deviates. There we go. All right, so that's our first measure, our point distance measure.